In this session, we're going to lay down some foundation before we get into corridor modeling. On my screen is an example of an assembly. The assembly is one of the three components necessary to build a corridor, the other two being alignment and profile. The assembly represents the typical section of your design. The actual assembly object is this vertical line right in the middle. Usually this passes along the crown of the road, although it doesn't have to. You can pass it along any linear aspect of your design. The assembly is then built from individual components called sub-assemblies. When we build an assembly, we drop the assembly in the drawing, and then it's like we go shopping for road parts and we start snapping these together to build our typical section. We'll do that in a little bit. Let me zoom in. I want to talk about what makes up an assembly. The assembly is made up of three components: points, links, and shapes. The points are these rings. Now, each of these rings has a code. If I hover over this one, for example, we can see it has the point code face curb. Let me hover over this one. It's called flow line gutter. Let me hover over this one. It's called sidewalk in. So from a programming perspective, each of these points knows what it is. This comes in handy for labeling purposes. For instance, you can see we've labeled the edge of traveled way here. So later on when we create cross sections, we can say I want to label edge of traveled way, I want to label the back curb. All I have to do is tell Civil 3D, go ahead and label all the back curb locations, and it knows exactly where they are because each of those points is coded. The other thing these points are used for, when we build our corridor, this assembly, this assembly that we see on screen is copied along our alignment and profile. It's just copied along that linear design. And each of these points then is connected dot to dot from one assembly insertion to the other. So if I hover over this one's face of curb, I would have a three-dimensional feature line then that connects all of these points called face of curb. So this is what creates the longitudinal geometry of the corridor. Next, the next component I want to talk about is links. Links are a connection between two points. These are also coded. Let me hover over this one. This one is called, it's got actually got three codes: sod, top, and datum. Let me hover over this one. This one's called daylight. Okay, so same principle. These come in handy when we're labeling. For instance, somebody labeled the sidewalk link. Somebody applied a label to the top of pavement link here. So when we create cross sections later, or when we create assemblies, or whenever we need labels for these things, we can go through and say any link that has a pave 1 code or a sidewalk code, I want you to put a grade label on there. The other thing the links are used for primarily is building surfaces. Back in the day, using some other CAD packages, we might have to trace the top of this object and use that to create triangles for a surface. Here, I can build the corridor, and I can go through and tell Civil 3D, I want you to build a surface from this corridor, and I want you to triangulate to any link that contains the top code. And then it automatically knows what to connect to because all of those links have the codes on them already. One more thing, anytime you have three or more links that create a closed area, that is called a shape. Shapes also have codes. Now I'm going to hover over this one on the bottom. So the shaded red area has the code base. This one might be the same thing. Yeah, base. Let me hover over this one. This one's called curb. So each of the closed areas is also has a code on it. This is used later when we're pulling material quantities. Back in the day, when maybe you made cross-section sheets and then you had to go through and trace all of these boundaries to do your average end areas, we don't have to do that anymore because each of these closed shapes is named. So I can go through after I create my sample lines and my cross sections. I can tell Civil 3D, I want you to tell me the quantity of the curb volume for this project, and it'll go through and do the average end area for those automatically. So the assembly is made up of three components: points, links, and shapes. And we'll talk more about these guys as we continue. But on our screen, we have an example of an assembly. In our next session, we will build one of these and create our first corridor.